Good day, guys. Welcome to IC Education, the only education that matters. Okay, here the problem is to calculate the stress at RST on the cross section of a column subjected to a load parallel to the axis, as shown at the point, and also determine the neutral, determine the position of the neutral axis and the plot. So basically, what we'll be doing, we'll be solving the stress at each point here, at this, and G. So how do we do that? It's quite easy. There is a formula for that. It simply says that stress is equal to P over A plus minus PHX IY plus minus PKY IX. I will explain what is PKX and what is PKY. So the thing to do when you have this type of problem, the first thing to do is to solve for AIX and then AIY and then IX. So let's start by doing what? What is the area? Because we have this rectangular here, it's going to be base times height, which is 60 times 0,1 or 0,1 times 0,06. That's the first step to do. So what is the answer? 86 times 10. I'm trying to do it fast to make the video shorter so that less than 20 minutes. So that's my goal for this video. Okay, now how do I find IY? How do you get IY? Remember, it is a rectangular. Now IY is passing at the center of gravity. Now we're looking at IY here. What are we gonna have? If we look at IY, remember the formula of moment of inertia passing through the rectangular bar, it is base times height cube over 12. So now if I have to find IY, what is this one? What does it mean? In such case, it simply means that my base becomes 60. So basically what you have, we're going to have 0,6 times 0,1 to the power cube, everything by 12. So if you do this calculation, you definitely going to get 5 times 10 to the power minus 6m4. Okay, now again we look for IX. Now because we are looking at IX passing through the center of gravity here, in this case our base is 100, the height is 60. So that's why we're going to have 0,1 times 0,06 cube, everything divided by 12. So what is the answer when we do that? We get 1,8 times 10 to the minus 6 and 4. So I believe that this is clear. The first step to do is to get the area, to get IY. If you're looking at IY, you're looking at Y like this, your base becomes 6, your Y becomes 100. If you're looking at IX, your base becomes 100, your height becomes 60. That's why we see we have a difference in IY and IX. So now, what does the formula says again? It says it is PHX. What does PHX mean? Yet again, I wanted to explain something. This load here, they call it a load point. It is a point located somewhere here, which is making a perpendicular distance with two axes, which is the x-axis and which is the y-axis. So it means it's creating two moment on the x and moment on the y. So for us to get moment on the y, it is simply force multiplied by the 60 multiplied by 40. If you want to get your moment on the x, it is 60 multiplied by 25. So that moment, it is simply what your book is calling P times H. P stands for the load, which is load. H is simply the distance perpendicular that creates the moment. Now, your x is simply here, the distance to where your point of study is, since you're looking at moment at R, to the center, yy. That is PHX. Okay. Let's do this to see how it works. So let's start by finding stress is at each point. Let's start by finding the stress at R. It says is P over A. P is the load, so it is definitely 60 times 10 to 3 divided by the area. What is the area? The area is 6 times 10 to the minus 3. Earlier on in class, we had a debate on what should be the sign because it is plus minus. Remember, you do not look at it as a Cartesian plane saying that this is positive, this is negative, this is positive, this is negative. No, these are just, it is not a Cartesian plane, it is just reference axis, like axis line, your reference line you're taking as study. I don't know how to say it in a better way, but what I'm trying to say, they are not determined as a Cartesian plane where you have positives and negatives. Nonetheless, in this case here, the way we determine the sign is quite easy. If this is point R and both of my distances here that create the moment, they are on the same corner. What do I mean by the same corner? They both are on this range here, on this corner where I'm doing my study. This simply means that these two should be positive. So that's one of the reasons here. We're going to have plus. Here it says PHX over IY. So because it is PHX over IY, the moment that should be here should be 60 times 40. The only reason because we are dividing by IY. Now, 60, so definitely we're going to get 60 times 10 to the 3 times 40 with a 0, 0.4, 0.04. Okay, so we got our P and H. What is the X? X is simply the distance where R is to YY. Because we are dividing by IY, so we'll go from X to the axis of YY. So what is that distance? It is simply 50 in this case, which is 0.05. Everything divided by IY. So what is IY? We just saw for IY, it is 5 times 10 to the minus 6. Plus now we're going to have 60 times 10 to 3 times 0, 0 times 0.025. Remember, it's the same thing. We are simply having the moment created now on the x-axis. Everything multiply. What is the distance? The distance is the same. It is simply where r is to yy, which is 50 again. So it is 0.05. Everything divided by ix. What is ix? 1.8 times 10 to the minus 6. So if you do that and you calculate this, it simply means your stress at R, if you calculate properly, you need to get the answer of 59 megapascal. Okay, I'm just gonna come back quickly about the sign. Why are we choosing this to be positive and positive? The reason is simply because this study of point R, you can see where the distance is that creating the moment R. They all are in the same quadrant with our point of study. Because of that, that should be positive. Now, can we move on point S? Rho S. S. Sorry. When we move on point S, remember it is still these same forces here that is creating the moment at the same distances. The only thing that is changing is the point S. So what does it mean? For you to get the moment at point S, it simply means that you are moving everything that you have here, your load, your distances, everything you are moving it under this quadrant. You can already see because you are moving on the opposite quadrant. As you can see, everything is being moved here. It simply means due to that, the sign here should be negative because you are no longer on the quadrant that has been given to us in the problem to study. You are shifting. I will also explain on the third case, you will see how it's going to change as well. But for this, because S is here, if you have to do this calculation, what is actually happening is you are jumping the x-axis. You are jumping 25. Like if you draw this line, let's say it's a line of 25, you want to bring it here, you are jumping 25 here. You are jumping this axis. Same apply with y. You are jumping y. Before you are doing all this jumping to have these dimensions here on this quadrant, definitely the signs here on the formula should be negative, but the moment will be the same. That's why you see for rho S, it is also force with a 60 times 10 to 3. I'll try my best to make this video shorter. Times 6 times 10 to the minus 3 plus plus the moment is the same. It is still 60 times 0.04 divided by this. No, it will not be plus, but it's going to be negative. But it is the same expression that we have here. 60 times 10 to 3 times 0.04 times, okay, now again, the distance of your x here is simply where your point S is to the yy, but that distance is also again 50. You can see full is n-red, all from 0 to 50, so that's why you see it's the same expression as the other one. Everything 5 times 10 to minus 6 minus 60 times 10 to power 3 times 0.025 times 0.05, everything divided by 1.8 times 10 to the minus 6. Okay, my guys, what do we get at rho S? If you calculate, you get negative 39 MPa. You do not have to worry about tensile and compressive. You need to worry about here is how to get the answer. Because your textbook is calling negative to be tensile, positive to be compressive. No, that does not make sense. So, okay, I'm going to repeat again about the sign. It is important. The only reason why at rho S we have the same expression, the sign difference is simply because we are moving these distances here to the other side. But by doing that, we are crossing axes. Let's say for x, you need to cross the x-axis. You cross the x-axis. For y, you are crossing the y-axis. I don't know how to say it to make sense, but what I'm trying to say is the distance 40 here, for you to have it, you are moving it to here. So it means if you need to move 40 here, you can see that you have already crossed the axis of y. If you need to move 25 here, you can see that you have crossed the axis of x. Because you are doing those crosses, these are the things that determine your sign. Now, can we do for point G that is in the middle here? Remember, our moment is still at that distance. What will change in this case is simply the distance of this x and y, because T is located somewhere here at 25 and 30. Now, here we go. Let's look at moment at rho T. Moment at rho T, it is force over area. It is 60 times 10 to power 3 divided by 6 divided by 6 times 10 to minus 3. Now, is it plus or minus under this case? Is it plus or minus? Okay, here we go. How do we determine it? The moment that we have here, it is 60. Let's see what's happening. We are now under this quadrant here. Let me zoom in and explain what's happening. We are under the quadrant here. Right? Now, it is still the 4, 60, and 25. But as you can see, if I move 40 down here, this is 40. As I'm moving 40, I am not crossing y-axis. I'm still on the y-axis. So, because of that, the sign of our moment about y should be positive. That is the only reason why that here you're going to have positive 60 times 10 to 3. The moment is 0.04. It's not changing. But what is changing here is the x distance. How do you get the x distance? It is simply where t is to y. What is that distance? 35. That's why you see times 0.035. Everything divided. I hope this video will be short, less than 20 minutes. So by the area, 5 times 10 to the minus 6. Now, can we look at the other moment there? For the other moment, how do we know it is positive or negative? Again, it is very simple. We still look at the quadrant that we are working in. But now, what is happening? You want the moment about this x. For you to get it, you need to move the 25 on the other side here. But by moving it, you are crossing this x-axis line. So by crossing, that's the simple reason that determine your sign should be negative, because you are crossing the x-axis of reference. I hope it's making sense. I'm gonna post this video earlier just this morning so that you can have time to look at it and ask me a question. I will answer you. So we have minus, again we go 60 times 10 to power 3 times 0.025. That is not changing. What is changing now is the distance from where g is to y. What is that distance? 0.20. That is your y in this case. Time 0.20. Everything divided by 1.8 times 10 to the minus 6. If you definitely do this calculation, you'll find out that rho at t is simply 10,133 megapascal. Now, that was the first question. If you look at the problem, the first question was to solve for determine the stress at each point R, S, and G across the section of a short column subjected to this parallel axis shown. That's what we did. We get R, S, and G, and that's how we do it. So the second thing they say, determine the position of the neutral axis. If you remember, I have explained in the beginning, the neutral axis, it is simply the point where it does not bend, where it is not subjected to any stress. So it simply means you take the general equation of this, you equate it to 0, definitely you can solve the neutral axis. So what do we mean by that to solve the neutral axis? We have rho. You know rho is equal to P over A. P is 60 times 10 to 3, everything divided by 6 times 10 to the minus 3. Okay, plus, is it plus or minus? Plus pH 60 times 10 to 3 times 0.04. Now we have x. Remember, now we want to solve for x and y. These are the points that determine the neutral axis. It is two different problems. When we are solving for neutral axis, we are not solving the stress at each point. At each point, they will specify RST. That's why we could find these x distances here. So this x distance here will help us to guess the position of the neutral axis. What is IY? 5 times 10 to the minus 6. So you go again plus. Where is the other guy? The other guy is 60 times 10 to 3 multiplied by 0.025 multiplied by the distance y over 1.8 is 1.8 times 10 to minus 6. Okay. What do we have? We have the neutral axis when rho is equal to 0. That's what's happening. So if rho is equal to 0, what does it mean? Remember, they are both sharing 60, 60, 60, 60. So you can take it as common factor, like when you take it out. I'm just going to explain to save time. And if you take it out, you bring it, you divide it by 0, because you bring it on the other side. The only thing that you'll have remaining here is going to be 1 over 60. So if we're going that fast, I just want to keep the video short. But what happened is this load is the same. If you take it as common factor outside, it will divide 0. So that's why it's going to be gone. To be equal to 5 times 10 to the minus 6 plus 60 will go, sorry about that, because we took it in common factor. Okay, this is what's happening here. Now remember, this can be an equation of 2 unknown. So 1 divided by 60 can go on the other side, so that it can be negative. I'm gonna keep it short. So what's gonna happen here? 1 divided by 60 here, if you calculate, it has to give you 0.012. Yeah, I'm just following the answers here. It's 0.02, so it means this guy can go on the other side to have the equation of x and y. So we're going to have minus 0.012 to be equal to this one divided by this. It gives you 0.576 x, and this one would give plus what is y? Ooh. They did it straight, they divided already. I don't want to do it step by step with calculation. It's gonna take some time. But what's the time already of the recording? It's been 23, which is more than what I was aiming to. So you see what is happening here. Okay, let me erase and explain what they did here. Okay, basically what they did is, guys, look, you have an equation of 2 unknown. It's like more or less like you're having 0 is equal to 2 plus 3x plus 4y. So what they did is they bring 2 on the other side, which is minus 2, to be equal to 3x plus 4y. Then they make y subject of the formula. So it means this has to come here. You're going to have minus 2 minus 3x, everything divided by 4, give y. This is basically what they have done on this example. So I'm just going to go to it quickly because I want the video to be short. So if you do it for this instance here, you'll find out that y will be equal to minus 0.576x minus 0.012. Now, how do you find the position of the central axis? This is a mathematical expression. If you know this, y is equal to ax plus b. It is an equation of the line. How do you solve for this equation of the line? It is simply simple. What you do is, if you remember in math 1 or 2, you have x and y. You simply give the value of x and y to see how you can. But the closest value that we give, we usually say if x equals 0, you know that y is equal to b. If b, we just play with value here. And if y equals 0, what will be a will, if y equals 0, x should be a over b in this case. That's how we play with this thing. Now you come on your Cartesian plane and you plot. That simply it means you have 2 points, x0, yb. Let's see b somewhere here. Second point is xa over b. Let's say that distance is somewhere here, and then y0. This creates a line. This is where your axis is. So we're going to apply the same here. That's simply what they did also here. You do have x and you do have y. So if x equals 0, it means your y should be negative 0, 012. And if y equals 0, you do the calculation, your y is going to be what they got as 0, 0.028. 2083. That's what they got. So it's the same thing. You come and you plot your graph. You show x0, y negative like this, and we have x0, y negative. We have y0, x positive. So our line will be passing here. This is where the neutral axis is, and that's how you're supposed to answer the question. Thank you. I'm gonna upload it now, and please watch it and ask me a question.